Okay, in this lesson, I'm going to talk about population, sample, and using your calculator to generate a simple random sample. I'm going to mention a few definitions. I mean, you can Google these things, look them up, and you'll find these definitions online. So I'm not even going to bother writing a lot of these out, but you can find them yourself. So now we give a bit of kind of a question first of all, or look at a situation where all this stuff might come into play. So this is an actual referendum that took place in 2018. It was a referendum to see if the Irish population would support the removal of the word blasphemous from the Irish Constitution. Okay? A referendum, everyone votes either yes or no. Yes, we want it removed from the Constitution. No, we do not want it removed from the Constitution. And there were about 3.5 million people that were eligible to vote in that constitution. Okay? A polling company, of which there are a few in Ireland, wanted to predict how the referendum would go. What would it have done? Okay? So that's kind of the question. A few things to mention, these words, population. And population in this case is everyone of interest in the survey. And really a referendum is just a big survey. You're asked a question and you answer it. So everyone of interest in the survey is part of the population. So the population consists of everyone in the survey. So the population consists of all the 3.5 million people who are eligible to vote in this case. So the polling company wants to predict how the referendum will go before the obvious referendum. One thing it could do, I suppose, in theory, is that it could go and interview all of these 3.5 million people and say, what way are you going to vote in the referendum? But it isn't going to do that. And take a second, pause the video, think, why is that not going to happen? Why would the polling company not just go and ask all the 3.5 million people in the population what way they're going to vote in the referendum? Okay? The reasons are really time and money. It would take too much time, and it would take a lot of money to reduce the time in any kind of significant way. So it's too expensive. So what the polling company will do is it takes what is called a sample. Okay, it takes a sample. So the polling company will sample. And one thing, I will write this one down. A sample is just a subset of the population. So that's what a sample is. It's a subset of the population. In other words, it's some group of people within this 3.5 million people. Okay, so the sample has to be people who are part of this 3.5 million people who are eligible to vote in the Irish referendum. Okay, so there's no point in going to Japan and asking a Japanese person how they would vote in this referendum. It wouldn't make sense. They're not part of the population, so that wouldn't be part of the sample. The sample would have to be somebody who's eligible to vote in the Irish referendum. So that's a sample. And there's lots of different sampling methods, and you will have looked at them. We'll be generating in a moment something called a simple random sample. A couple of other things to note is, I suppose, notation. And when you're dealing with any statistics, you have to understand the notation. So one thing we can talk about is the population. And the other thing we can talk about is the sample. And remember, the sample just exists within the population. The sample is a subset of the population. And I just want to talk about the notation we use. The first thing we might talk about maybe is the size of these things. What is the size of the population? Well, the notation we use for a population size is capital N. I suppose N for number, maybe N for the number of people in the population. And the notation we use for the sample, well, sample maybe it's a bit smaller, so we might use lowercase n. So they're the officially recognized symbols for population and sample. In this case, in this particular example, the sample or the population size is 3.5 million. And the sample size, well, that's going to be chosen by the polling company. The polling company wants to predict how the referendum will go. Would it be worthwhile to take a sample of size 1? Just ask one person in the 3.5 million population. No, it wouldn't make any sense. You wouldn't really be getting a good representation. Okay? Would it make any sense to ask everyone in the 3.5 million? No, not really. If I did ask everyone in the 3.5 million, that's called a census. A census is a sample that contains the whole population. In this case, we're not going to do that. It wouldn't make sense. So the polling company chooses a size of a sample. 1 wouldn't make any sense. 2 people wouldn't make any sense. There's not enough information. What they need is a sample, I suppose, small-ish, so it's going to save them time and money, but big enough so that they can take it to be representative of the population. We want to have all different parts of the population represented within the sample, and we really want them represented proportionately. Okay, so if half of the population identify as male, well then half of the sample should probably identify as male. If half of the population identify as female, well then half of the sample should probably identify as female. That's just the way it works. So maybe the polling company decides that they might sample 1,000 people. Okay? And then they will ask them different things. They'll ask them what way they're going to vote. Okay, what way they're going to vote. And what they'll do is they'll generate some kind of percentage of people who are going to vote yes. So what we have here is something called the proportion. So the proportion of the population is given the symbol little p. And the proportion of the sample is given the symbol p hat. And this is just going to be some kind of percentage. Ultimately you're saying, are you voting yes? And maybe in the sample of the 1,000 people, they said, are you voting yes? 600 said, yes, we are voting yes. In which case, the sample proportion would be 600 out of 1,000, or 0.6. And maybe in the population of 3.5 million, maybe there are, 2.8 million people who say they're going to vote yes. Well, then my proportion would be 2.8 million divided by 3.5 million, which I think works out as 4/5 or 0.8. Okay, so the sample proportion and the population proportion are not always the same. Okay, there are other kind of things we can ask. In this case, sample size is 1,000, population size is 3.5 million, population proportion 0.8, sample proportion 0.6. You just, to find the sample proportion, you put the number of people who are voting yes over 1,000. To find the population proportion, you put the number of people who are voting yes over 3.5 million. Okay? Other things, not in this particular case, but other things that can crop up are the mean. And the mean of a population is usually given this letter, mu. And the mean of a sample is usually given that symbol x bar. Okay? Again, this question, there's no real mean happening in this question if they're saying what way you're voting. And the other thing we've spoken about is standard deviation. And the symbol for standard deviation of a population is little sigma. And the symbol for the sample standard deviation is little s. Okay, so that's just a bit of notation. And this is these are important that we know and learn these little symbols, okay? Capital N is the size of a population. Little p is the proportion of the population. Mu is the mean of the population. Little sigma is the standard deviation of the population. Little n is the sample size. P hat is the sample proportion. X bar is the sample mean. S is the sample standard deviation. Okay? So that's what that polling company would do. And again, we'll come back and look at generating other things. We can also generate things called confidence intervals, which we'll talk about in another class. Okay? The next thing I'm going to talk about is generating a simple random sample. So the next thing I'm going to do is I'm going to generate a simple random sample. Okay? Now, in order to do this, I'm going to use my calculator. So I'm using this calculator here, Casio FX83 GTX. Okay, that's the calculator I'm using. It's this calculator that's recommended by our school, so that's the one I'm going to use. And I've also just made up a few names here. Imagine such a situation that I had this list of people here, okay, and I have 18 people in my list. Okay, and I want to, think about this as being my population. Imagine this is my population. So there's my population. There's 18 people. Abby, Alex, Alwyn, Ava, Kira, Clodagh, Ella, Enrico, Owen, Eve, George, Jamie, Michael, Molly, Rachel, Robin, Ruby, and Tom. Okay? Just some names that I've made up off the top of my head. They're my population. Okay? One thing I might think about is, again, let's think about population versus sample. And if I think first of all about the size of this population, how big is this population? Well, remember, for the population size, we use capital N, and for sample size, we use lowercase n. So the population size here is the number of people in my list in my population, 18. I've just chosen 18 because I don't really want to look at the 3.5 million people in the previous example. It's a little bit awkward. Okay, so that's one thing. That's the size. So I want to generate a sample. And I'm just going to choose a sample of some kind of size. I'm going to say, let's choose a sample of 5 people from the class. Okay, so I'm going to choose a sample of 5 people from the class. Okay, to generate a sample of 5 people, I'm going to use my calculator. One thing I might think about before I actually, and I'm going to zoom in a little bit here. Before I actually kind of use my generate a sample, I'm going to think, how many samples of 5 people are there within this 18 people? It's something to think about maybe. There's 18 people in the population. How many samples are there within that population of size 5? For example, Abby, Alex, Alwyn, Ava, Kira. There's a sample of size 5. It's a subset of the population. Here's another one. Abby, Alex, Alwyn, Ava, Clodagh. That's a sample of size 5. Here's another one. Abby, Alex, Alwyn, Ava, Ella. There's a sample of size 5. Okay, how many? And the way we find out how many is this. Okay, I want to see if I can make sure you're seeing this on the screen. So I have my calculator turned on, and I'm going to put in my population size, 18. And I'm going to use the shift function of the division key. So that's my choose button. So shift, choose. So we should see on the screen now 18C, and we read that as 18 choose. And my sample size I'm going to pick is 5. Okay, so 18 choose 5. And you can see that number there. There are 8,568 different samples of 5 people that I could take from this list. That's an awful lot. Okay. but I'm going to just generate maybe 1 or 2. Okay, so let's generate 1 or 2 samples. Okay, so let's generate our first sample. Let me call this my first sample here. And to generate a sample, all I'm going to do is use my calculator. And it wants to be, what I want to generate is called a simple random sample. And a simple random sample is just a sample in which every member of the population has an equal chance of being chosen. It's a nice, easy way to generate it on the calculator. So what I'm going to use, I'm going to use my random integer function on my calculator. So I'm just pressing my on or my all clear button just to have a blank screen. And I'm going to use the alpha function of this decimal point. You can see in the red writing it says random integer. So you should have that on your screen. And I'm going to put in the numbers from 1 to 18. So I hit 1. The comma is the shift function of the close bracket symbol. So I'm hitting shift, close bracket, and then I'm hitting 18 and closing my bracket there. And now every time I hit the equals key, my calculator is going to just come up with a random number between 1 and 18. So hit the equals key, and there's the number 7. So I'm going to take 5 people. So the first number I've generated is 7, then 10, and then 12, and then 17, and then 1. Okay, there's a sample of 5 people. So I'm going to look at who those 5 people are in my list. So person 7 first, well, that's Ella. So Ella will be in my sample. Person 10 is next, and that's Eve. So Eve is going to be in my sample. Person 12 is Jamie. So Jamie is going to be in my sample. Person 17 is Ruby. So Ruby is going to be in my sample. And person 1 is Abby. So Abby is going to be in my sample. That sample is a subset of the population, since every member of the sample is also a member of the population. Okay, so a couple of important details. Remember, why do we sample? We sample because to save time, and we sample to save money. That's essentially it. It's quicker and it costs less to take a sample rather than going around everyone in the 3.5 million. In my case, I reduced 3.5 million to 18 just for practical teaching purposes. Sample is a subset of the population. A sample containing the whole population is called a census. Notation we use, well, the size of a sample is capital N. The size of a population is capital N. Population proportion, little p. The mean of a population is mu. The standard deviation is sigma. Sample size, lowercase n. Sample proportion, p hat. Sample mean, x bar. And sample standard deviation is s. Okay. And then we generated a simple random sample using my calculator. Remember to see the number of ways I can choose 5 people from 18. It's 18, shift, division key, 5, hit equals. It should say up here, 18 choose 5. And that's the number of samples of size 5. So that sample that I took is just 1 out of 8,568 possible samples of size 5 that I could have taken. Okay? And that's what I'm going to talk about today. So we'll develop on that in the next class.